Alright, welcome back everyone. Today we're going to discuss about solving quadratics and square roots. This is going to be a workshop which has 4 objectives. Let us have objective number 1. I can solve quadratic equations. Question number 1. Use the quadratic formula to solve for x. Now, notice that there are no answer choices, and so when this happens, you can use Desmos. After plugging it in on Desmos, we have this graph which shows that your x is negative 2.5 and another value of x is 0.666, which in fraction I believe is 2/3. So therefore guys, those are the roots, or those are the solutions that you can plug in whenever you're asked to plug it in. Okay, so now let's go to example number 2. It says solve by completing the square. Again, there are no answer choices, and when this happens, you can actually plug it in on Desmos. Wrapping it on Desmos, you can see that your solution is negative 2 and 5. So you're going to plug those in. So your solutions are x equals negative 2 or x equals 5. I just want you to notice the ways that I had written the solution. This is one way of writing the solution, and this is another way. Both are acceptable ways. So let us look at example number 3. Find the roots of this quadratic equation. You are given some answer choices, and notice that your answer choices have i's. When that happens, you will have to do it by hand. The formula that I'm going to recommend in order to do this is the quadratic formula. Let's go over the quadratic formula once again. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Please remember that the standard form of quadratic function is y equals ax squared plus bx plus c. So then, this is your a. It's the number in front of your x squared, which is, if there is no visible number, you know that that is a 1. Your b is negative 2. It includes the sign. And your c is positive 5. I always recommend writing back down the formula, and then whenever you see your variables a, b, and c, to replace them with parentheses. And then now we're going to plug them one by one. So this is your negative 2, which is your b. Then plug in again the negative 2 in place of b. Plug in the 1 in place of a. Plug in the 5 in place of c. Plug in the 1 in place of a. After you plug them all in, you can now start solving. Negative times negative is positive 2. Copy the plus and minus and then the radical sign. Negative 2 inside the parentheses squared is going to be a positive 4. Then for all these, it's negative 4 times 1 times 5 is negative 20. 2 times 1 is a 2. Copy them down, so x equals 2 plus or minus 4 minus 20 is negative 16 all over 2. Okay, you all know that we need to get rid of that negative 16, and we have to make it positive by separating it with negative 1 times positive 16 in order for us to operate this and get the imaginary number. Once you have done that, you know that your square root of negative 1 is equivalent to I. So now you all know that this expression right here, which I placed here, is going to equal to 4i, and the reason for that is because 16, square root of 16 is 4, and the square root of negative 1 is I. So this whole expression is equal to 4i. So now we are almost done. This is now going to be equal to 2 plus or minus 4i all over 2. The only thing we need to do now is get their factor out, their common factor, which is a 2. When you factor out the 2 on both of these terms, it's going to come out for this first term as 1. And then this is plus or minus 2i. And then of course all over 2, which will cancel out. Final answer will now come out as x equals 1 plus or minus 2i, which has actually 2 meanings. It means that x equals 1 plus 2i, or x is equal to 1 minus 2i. Therefore, for question number 3, our answer is letter B. Let us now go to problem number 4, which again is better done by paper. So we are going to show the zero property for this one. Okay, so you're going to get this factor and you're going to put it as equal to 0. And you do the same for this binomial factor on this side. And so now your answer is x is equal to x negative 5 and x is equal to positive 3. So our answer for this one is letter D. Let's now go to example number 5 and let us do this by hand. The first step you're going to do is you will have to put this expression under the radical sign in order to remove the squared. Whatever you do on this side, you're also going to perform and do on the other side. So now there's no more square there, it's just this, and then on this side you have plus or minus square root of 8. Okay. So I hope by now that you know that the shortcut in order to remove the positive 5 on this side, the shortcut is to just move it on the other side, but make sure to change the sign. And then I just bring this down on the side of negative 5. Square root of 8 can be simplified by 4 times 2, and you know that 4 is a perfect square, so this will go out of the radical sign. So let me explain what happened here. So the square root of 4 is a 2, so which is there. And then this 2 has no pair, so this will have to stay inside the radical sign. To rewrite it, a is equal to negative 5 plus or minus 2 square root of 2. I just want you to get used to looking at this and knowing that there are two solutions there, which are negative 5 plus 2 square root of 2 or negative 5 minus 2 square root of 2. Let's look at the answer choices. The answer is letter A. Objective number 2, I can solve quadratic inequalities. Which of the following is a solution to the inequality? Plug this in on Desmos. After you plug it in on Desmos, you will look for the point that is on the shaded part of your graph. That point is a solution if it is on the shaded part of your graph. Okay, so let's analyze 0, 5, 0x, 5 is y, so that is not on the shaded part. 0, negative 3 is on the graph itself, and the graph is solid, so that is a solution. Let us analyze all the rest. Negative 1, negative 2 is right here, so that is not a solution. Negative 2, 7 is right here, so that's not a solution. The answer to this one is letter B. Example number 2, given negative 3, negative 1, and 2, 0 are solutions to the following inequality, what symbol goes in the box? So what you're going to do here is really just trial and error. You're going to plug it in on Desmos, starting with letter A. You're going to use that symbol and see if those points are in the shaded area. Okay, after plugging it in, examine your 2 points if they're on the shaded area. This one is negative 3, 1, so that is correct. However, the 2, 0 is right here. Both of them must be on the shaded area because both of them are solutions. Therefore, letter A is wrong. Go ahead and try the next one. Alright, so the next symbol is greater than or equal to, so I have that there. Let's examine it. So, with that, I have my negative 3, negative 1 is still in the shaded area or along the line, which is solid, which means that that is a solution. And I have 2, 0 right here, which is also part of the shaded area. Therefore, your answer is letter B. So on objective number 3, I can solve and identify extraneous solutions to square root equations. Example number 1. What's the value of x in this equation? This is very easily done on Desmos. What I will recommend you do is to just plug this all in place of x and see which comes out as 4. When I plugged in letter A in place of x, it came out as 3.6, which is really not a 4, so try 17. I plugged in B, it's also not a 4. When I plugged in letter C, which is 18, it did not come out as 4. By the process of elimination, the answer is letter D, and let's take a look at that. When I plugged in 19, it came out as 4, so the answer for this is letter D. Let us now take a look at number 2. Okay, for number 2 example, I want to go ahead and show it to you by hand, because what if there are no answer choices? There are no answer choices, you will be forced to do it by hand, so I'm going to show you how to do that. We're going to go ahead and remove the radical sign, and to do this, we're going to square both sides. That exponent of 2 will now be applied to both the 3 and the expression inside the radical sign. Notice that the 3 was squared, it became a 9, and notice that for this one, the radical sign had already been removed, and this became 81. We're going to distribute the 9 to the 2b and to the 5, having this now. And I want to show you that the positive 45 went to the other side and turned to a negative 45. The 81 was just brought down. And then you're going to bring down 18b on this side. 18b equals 36. You're going to divide both sides by 18. And so now b is equal to 2. And your answer for this one is letter A. Okay, let's try this one again without technology. Square both sides to remove the radical sign. So on this side, the radical sign had already been removed, and on here, we're going to apply the exponent 2 to both 2 and 3, making it become 4 out of 9. What's left on this side is 3a. The negative 2 over 9 went to the other side, and the sign changed. Plus 2 is 6 out of 9, and you're going to solve for a. Some of you may question this and say why we did not divide by 3. Well, because that is also an acceptable way to do it. Dividing by 3 is the same as multiplying by 1/3, and the reason why I did that is because here, we're dealing with numerator and denominator, so that is much easier. So now that will be canceled out. For this, 6 divided by 3 is 2, so now it's just 2 over 9. And your answer here is letter C. What is the extraneous root of this equation? Let us begin. Okay, so first step is put the positive 4 to the other side, making it become negative 4. Square both sides to remove the radical sign. You will have to solve this by multiplying this binomial with that binomial using FOIL, or you can just distribute. We got that by distribution. Just move this to this other side. Then combine like terms, combine your constants, factor them out. X squared will be x times x. For positive 21, I chose negative 7 and negative 3 because if I multiply them, it becomes positive 21, but when I add them, it becomes the middle term. We will apply the zero property. Then now we have x equals 7 and x equals 3, and we will find out which one is the extraneous by going back and checking. So in place of x, we're going to put 7, and we're going to solve and see if it equals 7. Our original equation. 14 minus 5 is 9. The root of 9 is 3, plus 4 is 7. So 7 is a correct solution. So that is going to be 3 there. We're checking for 3 now. That will be 6 minus 5. Sorry about that. This was supposed to be 3. Okay, so 6 minus 5 is 1. Square root of 1 is 1. So we will put 1 here. Plus 4 is 5 equals 3 is an extraneous solution. Again, 1 plus 4 is not equal to 3. And so because of that, x equals 3 is an extraneous solution. Our answer to number 4 is letter A. Let us now do objective 4. I can add, subtract, and multiply complex numbers. Example number 1, what is equivalent to this expression right here? Go ahead guys and do the FOIL method here, or you can simply just distribute. Go ahead and expand it. Times 3 is 9. 3 times negative 2i is negative 6i. Negative 2i times 3 is negative 6i. Then negative 2i times negative 2i is positive 4i squared. So now we simplify 9 minus 12i plus 4i squared. So 9 minus 12i plus 4i squared is negative 1. So therefore that will be 4 times negative 1. So that will be 9 minus 12i minus 4. Final answer is 5 minus 12i, which is letter D. Let's now go to example number 2. Multiply the following complex numbers, simplify. You're going to use the FOIL method or just the same distribute. Times negative 5 is negative 10. And then 2 times 4i is positive 8i. 3i times negative 5 is negative 15i. And then 3i times 4i is positive 12i squared. Simplify and substitute negative 1 in place of I squared. Our answer is letter B.